Okay, for this question, we're told that AC is equal to CD, and the measure of EBC, which would be here, is 45 degrees. And the measure of ACD, which will be here, is 104 degrees. What is the value of X? Okay, so let's start by labeling some things that we know. So since we're told that AC and CD are the same, that means that their angles, D and A, are the same because there's a relationship between the length of a side and its corresponding angle. So the angle on this side has some relationship here, and the angle on this side has some relationship with the side here. And since we're told that CD and CA are the same, their angles must also be the same. So let's just denote that by using the same color there. So we also know that all straight lines have 180 degrees. So when you segment it, cut it off there, the angle here plus the angle here must add up to 180 degrees. So we can start by saying that this angle, BCA, can be solved by saying 180 is equal to 104 plus that angle, and let's call that angle Y, which means Y is equal to 76 degrees. And we also know that all triangles must add up to 180 degrees. So since we have 45 and 76, we can say 180 is equal to 76 plus 45 plus some angle Y. And solving for this, we get that Y is equal to 59. So this angle here is 59 degrees. And another thing that we know is that whenever you have two line segments intersecting like this, the angle here is equal to the angle here, and the angle here is equal to the angle here. So that means that we know that the angle over here is also 59 degrees. So we're almost there because we know that triangles are 180 degrees. If we could find this angle A, we can figure out what angle X is. And we can get that because we were given the information that DC and CA are the same. So that means that 180 has to equal 104, this angle here, plus the angle at D and the angle at A. But since that we know that they're exactly the same, we're saying that 180 equals 104 at the given angle, plus whatever the angle D is and whatever the angle A is. So let's just call that Y, plus another Y, because we could call this angle Y, call this angle Y. So this is saying Y plus Y, 180 is equal 104 plus 2Y, and solving for Y, so Y is equal to 38, which means this is 38 degrees, and this is 38 degrees. So X is going to be 180 minus 59 minus 38. So solving for that, we get X is 83 degrees. So for this question, we are told that QRST lie on some segment PV, and RU intersects them at SX, and SQX is 48 degrees. So SQX, so right over here, is 48 degrees. And SXQ, so right here, is 86 degrees. And SWU, so S to W to U, so it'll be this one right here, is given as 85 degrees. And VTU, so it'll be this guy here, is 162 degrees. What is TUR? So we're looking for this guy. Okay, so let's start by finding the angle here. So we know that whenever you have a straight line with some cut, the angle here and the angle here must add up to 180 degrees. So that means 162 plus some angle X has to equal 180, which means X is equal to 18. So this is 18 degrees. And we could find this angle here because we know that all triangles must add up to 180 degrees. And we have 48 plus 86 plus that angle, we'll call x, has to equal 180 degrees. 6. So this is 46 degrees. And we could find the angle here using the rule that when you have a straight line with a cut, it has to equal 90 degrees. So that means 180 has to equal 85 plus x. So solving for that, x is 95. So this is 95 degrees. And using the rule that all triangles must add up to 180 degrees, we can say that 180 is equal to 46 plus 95 plus x. So solving for x is 39 degrees. So this is 39 degrees. So now we can finally find the angle for u, because all triangles must add up to 180 degrees. So 180 is equal to u plus 18 plus 39. So that means u is equal to 180 minus 18 minus 39 is 123 degrees. So for this question, we're told that point O is the center, and OAB, which would be this angle, is 30 degrees. And if OC is 18, the radius is 18, what is the length of this arc AB? Okay, so first let's start with the equation for the length of an arc. So the equation for the length of an arc is 2 times pi times r, the radius, times theta, which is the angle of interest, over 360. So basically, if we can find this angle AOB, this guy right here, then we could find the length of this arc, because we already know the radius is given to us as 18. Okay, so we know that all triangles have a relationship between their angles and their corresponding sides. So this angle looking here has a relationship, and this angle here has a relationship, and this angle here to here, this side has a relationship. And since this triangle is inside of a circle, we know that from the center point outwards to anywhere else on the circle, that is the radius. And so if this is A, and this is B, and this is O, we know that this length, O to A, and this length, O to B, they're both the radius. So they're equal. They're both 18. And since they're both 18, you know that this angle has a relationship here, and this angle has a relationship here. And since those sides are the same, you know that this one also has to be 30 degrees. And since all triangles have to add up to 180 degrees, 180 is equal to 30 plus theta, what we're looking for, which means theta has to equal 120. So just plugging everything in, we have 2 times pi times the radius, which is given to us as 18, times 120 over 360. So now we have 2 pi 18 times 1 over 3. So we have 36 pi over 3, which is equal to 12 pi. Okay, so for this question, we're told that there's some triangle XYZ, and Z is a right angle. So you have Z is the right angle, and let's make this Y, and let's make this X. And so YZ, we're told, has 24 units, and the tangent of X over here is 12 over 35. What is the perimeter? So we know the tangent is equal to the opposite over the adjacent. And we're told that the opposite side is 24. So, but we're also told it's 12 over 35. So the perimeter is the sum of all the sides. So we first need to find what is this and what is this. Okay, well, since we're told that the tangent of x is 12 over 35, what we know is the opposite over adjacent, which is 24 over the adjacent. So you can solve for the adjacent by cross multiplying, or you could recognize that 12 times 2 is 24, which means if we multiply this entire fraction by 2 on top and 2 on the bottom, we can find the adjacent. So 12 times 2 and 35 times 2. So you get 24 over 70. So the adjacent side is 70. And you can find this side with the Pythagorean's theorem, saying that a squared plus b squared is equal to c squared, where c is the hypotenuse, the side opposite of the 90-degree angle. So solving for this, you get c is equal to the square root of a squared plus b squared. So the perimeter is just summing everything together. So we can say 24 plus 70 plus the square root of 24 squared plus 70 squared is the perimeter, P. So throwing all this into a calculator, you end up with 168. So for this problem, we are told that there is some circle with a center at -1 and 1, and there is a line tangent to it at 5 and -4. And so tangent means that a line will touch this circle at one point and only one point. So you could solve this with Desmos, but I would first want to show how to do this by hand so you get an idea of what's going on here. So in order to find out which one of these points lies on this line, you need to know what the slope of this line is. If you know the slope of this line, then you know how much you have to rise and how much you have to run to get to the next point on this line. Or likewise, you can how far you need to go over and down to go below it, because we don't know if the answer is going to be above or below. So how do we get that slope? Well, you notice that we have 2 points, the one at the center and the point of intersection. So you make a line like this, you can see that these 2 lines are perpendicular to one another. And the relationship of slopes of perpendicular lines is the negative reciprocal. So if we could find the slope of this line, which we can do because we have 2 points, then we could find the slope of this line. So let's start by finding the slope of this line here. Okay, so we know the slope is y2 minus y1 over x2 minus x1. So m is equal to -4 minus 1 all over 5 minus -1. So m is equal to -5 over +6. So that's the slope of this line. But we want to find the slope of this line, which is the negative reciprocal, which means that m is equal to 6 over 5, and we flip the sign, so +6 over 5. So what we can do now is just look at all of our answers and see if they align with our slope, meaning if we go up and over, rise over run, will we run into one of these points? Okay, so let's start there. So we have 5 and -4 as our starting point. So how much do we need to rise? Which means our y-axis has to go up. So -4 plus 6 gives you 2, and 5 plus 5 gives you 10. So our coordinates is 10 and 2. And that just so happens to be the answer right here, because we need to go up from 4, up by 6, and then over by 5. And we can do this in Desmos. So we know the equation for a circle is x minus the x coordinate of the center. So in this case it's -1. So that'll be x minus -1 is +1 squared plus y minus the y coordinate of the center, which is +1 squared, is equal to the radius squared. In this case, it doesn't really matter what the radius is because we're just trying to create the circle. We're not really trying to find what the value of r is. So let's make a slider for r, since that is our constant, and we don't know how big it's going to be right now. But we know the point of intersection is given to us as 5 and -4. So if we could adjust our r until we hit that point, Right, well now we know the equation of our circle. So this equation should actually be r squared. I'm just putting it here as r to make the slider easier. So now what we can do is insert a table and type in 5 and -4, because that is our point of intersection, and just type in every single answer choice into Desmos. So A is 0 and 6/5. And when you click on this line, you can see that we have more than one point of intersection, so that's not the tangent line. And so going to B is 4 and 7. Well, that is also more than one point of intersection, so that's not the correct answer. And finally C, which is 10 and 2, and that has one point of intersection, right exactly at 5 and 4, where the problem tells us that that point should meet that line. For this question, we're told that there's some triangle ABC where B is 90 degrees and there's some altitude. Okay, so let's draw that. So we have some triangle with 90 degrees at B with some altitude at D. So they say A and this is C. And we're told that AB is 15 and that AC is 15 plus 23 because it's 23 greater. So that's the same as saying 38. So what is the value of BC over BD? Okay, so we don't really need to find what BC and BD is, because this question wants you to recognize similar triangles. So two triangles are similar to one another if they have two angles which have the exact same value for their angles. For example, let's say we have some triangle XYZ and some triangle MN and O. So let's say X and M are exactly the same, and let's say Z and N are exactly the same. Well, that means there's similar triangles because they have two angles that are exactly the same, that are congruent to one another. And do we have this relationship in this triangle? Well, yes, there's actually three triangles in this problem because we have BAC, and then we have BAD, and we also have BDC. Okay. So for this particular problem, we're interested on the right-hand side because we're looking for BC and BD. So we know that there is a right triangle here and here because of the segment, this altitude. So let's draw this separately, and it might be easier to see. So we have B, D, C. But the 90 degrees on the big triangle, BAC, is on top. Okay, so let's rotate this. So if we do that, you have D here, B here, and C here. Well, that's not exactly the same, because the angles that are shared is angle B corresponds to angle D because they're 90 degrees, and angle C corresponds to angle C because this triangle is baked into BAC. So we know that it has to be angle C that's corresponding to it. So let's just flip this triangle over. So if you flip it, you get this. You have D here, B here, and C here. Okay, so let's make this statement. We have this statement that triangle BAC is similar to triangle DBC. And the relationship between similar triangles is saying that there is a ratio of BA to DB. So BA has some relationship to DB, and AC has some relationship to BC. Okay. So that means that the ratio of what we're looking for, BC over BD, is the same as saying AC over AB. Because we have BC, AC, and then BD and AB. So do we know the value for AC? Yes, they told us it was 38. And do we know the value for AB? Yes, we were told it was 15. So the answer is D, 38 over 15. So for this problem, we're told that there's a right circle cylinder with some radius r and a height of h, and a second one which is not shown to us, which we can just draw here, that has a volume that is 392 times larger as the volume of this guy. So which one of these could be the r and h? Okay, so first we need to know the volume is pi r squared times the height. This comes from the area here, and then you multiply by height to get the volume. So we know that pi r squared times the height is equal to 392 pi big R squared and big H. So we could just plug in all these terms here to see at what point do we get 392. So for 8R and 7H is 8 squared times 7, 392. No, it's 448. And is 8 squared times 49, 392. No, that's 31,036, or 3,136. And is 7 squared times 8. Yes, it is. It's 392. Which means the answer is C. So for this question, we're told that ADC is 5 pi, and this angle x is 100 degrees. And what is the length of arc ABC? Well, there is a relationship between the length of an arc and their corresponding angles. So if we call this arc length S, we can say S over 5 pi is equal to theta, calling this theta the opposite end of this angle that was given to us, over 100. And we know that all circles have to be 360 degrees. So you can say S over 5 pi is equal to 360 minus 100 to get the other side, 260, over 100. And you can solve this by cross multiplying. So you can say 100S is equal to 5 pi times 260. So you can say 260 times 5 is 1300. So 100S is equal to 1300 pi. And divide this by 100, you get S is equal to 13 pi. So the answer is B. So for this problem, we're told that in some triangle XYZ, Y is a right angle. And angle Z is 33 degrees. And the length of YZ is 26 units. If the area of a triangle can be represented as K tan of 33 degrees, what is the value of K? Okay, so we know that the area of a triangle is 1/2 base times height. That is the area. So we know that we can find this length because we're told that this angle is 30 and we use the tangent. Because the tangent is equal to opposite over adjacent. So the tan of 33 is the opposite, which is the length xy, over the adjacent, which is 26. So we can solve for xy by saying xy is equal to 26 times the tangent of 33. So xy here, let's put this in a different color, is 26 tangent of 33. 26 tangent of 23. So which means our area is 1/2 the base, which is 26, times the height, which is 26 tangent of 33. So multiplying this out, you get 338 tangent of 33. And so we are this same form, K tan of 33. So that means K is 338. And that is the last problem for today.